or 3.7 times 10 to the 10th disintegration per second is equal to 1 Curie. And so you always put your conversions and then look to cross out the units you don't want, keep the units you do want. You keep working the problem until you find out the units that you desire. All right, so that's one kind of common conversion, is the use of conversions in radioactivity. Another thing we like to convert is very, very small units of energy into larger units of energy. For example, when we have a nuclear fission, we have a nuclear decay, how much energy does that gamma ray come off with? How much energy does that beta minus particle come off with? The positron, all these things. And a lot of times they come out in the order of about a mega electron volt. Well, before we get going here too far, just to let you know, an electron volt, EV, is a unit of energy. So EV is a unit of energy. And it's equal to the unit of energy if you had a 1 voltage potential between a couple of plates. So let's take 2 electric plates. We'll make one positive, one negative, and we put 1 volt of electrical potential between them, and then we just put 1 electron right here. We know that opposites attract, and so that electron here, which is negatively charged, will go screaming towards the positive plate and away from the negative plate, and it would gain exactly 1 electron volt of energy in that. How much is an electron volt of energy? Several, a lot of times we like to talk about, in all practicality, one nuclear fission in a nuclear power plant, converting 1 atom of uranium-235 and fissioning it, gives you about 200 mega electron volts. So it'd be like having 200 million of these electrons in 1 voltage potential. Well, how much energy is that? That's not even enough energy to even make one of the little hairs on a feather move. Okay, it's very, very, very small. However, it's how many of these fissions do we have going on? Oh, well, let's take a look at this. On average, for every watt of thermal energy that we make at a nuclear power plant, we have 3.12 times 10 to the 10th fissions going on every second. So even though each one of these nuclear fissions do not put off very much power, if you got 3.12 10 to the 10th of anything going on every second, all of a sudden you can start making some real power. So let's just take a look at maybe how many fissions are going on out at your local nuclear power plant. And so we'll do that. Let's take a look at your local nuclear power plant. Probably is rated at about 1,000 megawatts of electrical power. Now, not every megawatt of electrical power, we can't convert all energy into electricity. There's always waste. Nothing is 100% efficient. And it turns out that most nuclear power plants are about 33% efficient. Okay? So we waste 2/3 of the energy and we keep 1/3 for the actual electrical. So if we got 1,000 megawatts electrical, and for every watt of thermal, we have a 3.12 times 10 to the 10th fissions going on per second. For this plant, let's find out when it's up at 100% power, that's what this 1,000 megawatts electrical, that's when it's up at 100% power, how many fissions are going on every second out there? So let's take a look at that. One of the things you want to ask yourself many times in unit conversion is, what am I looking for? Well, what was the question? The question was, how many fissions per second? So many times you would like to put that in the numerator. Just put it right up there and say, my question is fissions per second. Because if you don't, what will happen is your answer will end up in the denominator, and no human being thinks well when there are variables in the denominator. We want things up in the numerator where we can think about it. And so you start saying to yourself, okay, my answer needs to be in fissions per second. What do I know about fissions per second? Well, on the board, I've erased it now, but on the board I had a conversion factor that 3.12 times 10 to the 10th fissions per second was equal to 1 watt of thermal power. All right? Now, be careful whenever you get going here. We want fissions per second. So don't ever find yourself crossing out fissions per second. As soon as you cross out fissions per second, you're sunk. Okay? So let's keep fissions per second up there and make sure we never cross that out. Some of my students will circle fissions per second. They'll actually do this and say, and that will indicate to them, don't ever cross through the circle. If you cross through the circle, you're sunk. All right? So circle what you want, and then you can cross out everything else. So we want fissions per second. We got 1 watt of thermal power. So this 33% efficient, what's that really mean? What that means is for every thermal watt of power that we produce, heat power, we only get 0.33 watts of electricity out of it, electrical power. Okay? So you can convert percent efficiencies into other units. So here, using this relationship down here, we can say that, well, 1 watt of thermal power at the reactor plant produces 0.33 watts of electrical power. So now we can cross out watts thermal and watts thermal. Now we know how many fissions per second we need for every watt of electrical. I didn't write this very well. Let me correct that.